Okay, so we're going to look at matrices, and to start with we will look at matrix structure. A matrix is a rectangular array of numbers which are organized into horizontal rows and vertical columns, and we can see that here. We normally denote a matrix with a capital letter. So this is the matrix A, and we can see that it has 3 rows and it has 2 columns. So 3 rows and 2 columns means we call it a 3 by 2 matrix. So when we name the order or size of a matrix, we do the number of rows multiplied by the number of columns. As I mentioned, capital letters are used to name the matrix. Each value in a matrix is called an element of the matrix. So 3 here is an element of this matrix. We can also state what the position is. So the element 3 there, we'll probably come to this further down as well, but I'll mention it now, is element A12. It's the element that's in the first row and the second column. So the first row and the second column. And 4 here would be A31, third row, first column. So the order of a matrix is important. We'll see why a bit later on through the notes. So we want to look at this table below that shows the types of rooms available at 3 different hotels. So we've got these types of rooms here, the single, the queen and the family suite, and these are 3 hotels. And to get a matrix, which I've called F, from this, what we've done is stripped away the headers, and we just get the array of numbers. Okay, so we'll come across these as we go through. A column matrix just has a column, a row matrix just has a row, so that's fairly obvious. Square matrices have the same number of columns and rows. This is a 2 by 2 matrix. This one here is a 3 by 3 matrix. A zero matrix, I think we're going to make this a bit later on, has zeros everywhere. It doesn't have to be square, the first 2 are. It just has zeros everywhere. Identity matrices are always square. So this one's called I2 because it's the 2 by 2 identity. And this one's I3, which is the 3 by 3 identity. And identities always have 1s on what's called the leading diagonal, the diagonal that goes that way. And they have zeros literally everywhere else. So we can see in this one, we've got zeros everywhere except on that leading diagonal. Okay, remember which way the leading diagonal goes. So, example 1. State the order of the matrix A, where A is this matrix here. Well, we can see that the matrix has 2 rows. And we can see that the matrix has 3 columns. So therefore, it's a 2 by 3 matrix.